What a boring working day it is. I have a lot of things to do, and my home is so far. I need to drive 2 hours straight to my home. Indeed, that's a problem of a lot of people in Australia that lives in the rural areas. Wait, did I lock the door? How can I know? In traditional way, I can't. But thanks to this new technology called IoT, I can basically access to all of my home network via one button when I'm in my office. See, I guess I didn't lock my door, but right now it is locked. Hello, today I'm going to show you how will I do my rural home network and rural office network and how I did connect this via the Cisco Packet Tracer software. To doing this, I want to mention about something. A major 20% of Australia's population lives in the rural areas, and they have rural homes and rural offices, which have a lot of climate and environmental issues. As you may remember and recall, just a few years ago there was a giant bushfire in Australian bush, and it's a big threat for a lot of rural offices because these rural offices have damaged things. A sudden temperature change in this office can cause maybe a major bushfire like that. And by making an IoT network for these kind of rural offices, I aim to making people's life more easier for these employees, because most of them are really far homes to their offices, so they need to drive long hours when they need to go to office or the home immediately, and also ensuring that their offices and the homes are safe, so they can be able to watch their home anytime, and they be able to check the climatal data in their offices anytime. But before starting that, I want to talk to you about something. What is IoT? IoT is basically any devices that is connected to internet. It's a pretty new subject. So if you connect any devices to internet via IP, is being the part of the IoT network right now, and you can basically control it technically from anywhere as long as you have the right connections. So in my network, the IoT network that I will going to do is going to be pretty simple actually. There's going to be two separated networks, which is for rural offices and the other one for rural home. So when you in the rural office or at rural home, you'll be able to access the IoT devices in these servers. So I'm gonna use two home gateways, which is a local wireless devices that you connect in that network for these offices, a home gateway for office and a home gateway for home. And these home gateways will have four IoT devices connected to them each, and all of the devices are going to be aiming to our purpose, which is a safe home and environmentally safe rural office. So in home, I'm planning to use coffee machine because obviously people like coffee, and when you drove so much you just want to have a coffee at your home. Also a garage to get access to your home when you're out of the home. The door, obviously be sure that your home is secure, and also the webcam if you have maybe a kid or any thief situation, any other situation to be watched, to be sure from the home there's going to be a webcam. And for a rural office, it's going to be mostly environmentally device like thermostat and other things. And also I'm going to put a fan if the weather is so hot, you can open the fan to be ensure of the environment, because as you know, Australia, a lot of time that these temperatures may go so high. So for connecting these two networks to each other, I'm going to use two the network devices. One is switch. This is going to allow these two networks to have a common communication between them. So it's going to be kind of like bridge between them, and also basically the IoT server where all the magic going to happen. Thanks to this IoT server, any person from, for example, the office network will be able to access both in its network IoT devices and remotely to his home devices. So they're going to meet at the IoT server thanks to the switch. I'm going to use a 29/6 switch, which is one of the safest ones and more easily accessible ones. I'm going to connect these ones via wire for each side, the automatic wires, cable wires, and they're going to be one is from the office and the other one is the home, and they're going to connect it that switch. And from switch, I'm also going to have one more cable to the server, so they basically going to be connected to server via switch, both of them, and from that server you'll be able to access. I should have organized the IP of the server and other things like technical details that we were going to go through in the video that I will show. I want to mention about system and data security in IoT networks. So basically, there's a bunch of protocols that these IoT networks use. For to be specific to this one, I'm going to use two major cybersecurity protocol, which is SSID and WPA2 passphrase. So SSID is basically the identifier of the local wireless network, which is home gateway in my case. So thanks to these SSIDs, they will be able to connect my IoT device will be able to connect those wireless devices, but this is not going to be enough because as long as any potential IoT device that has that SSID will be able to connect my device, which is going always not safe. But to make it safer, I'm going to use a protocol called WPA2-PSK, which basically is kind of like Wi-Fi password that we use at homes. So thanks to this protocol, you need to have a unique identifier password to access to each wireless devices, and only the host of that wireless devices can change the code. I'm going to put two different codes for two different wireless networks. The first one, the home one, is going to be stay sharp, and the other one is going to be not sharp. So you for these each IoT devices that is connected in these networks, they have to have this unique password to get connected, and thanks to this, it's going to be encrypted in the way of AEC, which is basically kind of a protocol and more deeply. In more complex networks, there are also different ways of to provide these connections, like maybe blockchain technology is one of these good answers. It's basically have a centralized network that each computer should access. It's a bit complicated mathematically thing, but it's real. Thanks to these uncentralized network, each computer should allow the transaction of data to be approved, and that data is good, but it's always way more hard and it's way more complex. It's not really as for a simple network like I will do, but it's for more brain networks, and these are most securely collected data. So one of the other important topic is how data is used in these enterprises. So in my one specifically, the main data is going to be safety of that user. So the user will be able to access their information of their office, for example temperature of the office, and then make the decision about the making change in those IoT devices, like open the fence maybe, those things. But and also, as I mentioned previously, encryption is going to be one of the main data thing. But in the other data, it's mostly maybe bandwidth, which I will not going to go in this one, because as I say, it's quite a simple network, and its bandwidth is for more deeply and more connected devices. Since I just have two separate network, I didn't need any fine to go for bandwidth. Also, the user feedbacks, like in complex networks, it's really important to have these user feedbacks. Other than that, mostly the size of data is really important, like how many data it comes, and also how many devices are connected to that network, because it's also always a change. So these data things are really important. So lastly, I want to mention about the innovation and the ethical issues of this network. So it's basically bringing innovation to the rural areas, because as I say, most of these rural areas are really remotely to each other and they need to have a connection. So these network going to provide this connection between the workers at home and to the workers at office. So sorry, the people at home and the workers in the office. So going to be ensured from both of these safeties of the locations, both office and the home. This can be also applied to the city, but I specifically choose the rural areas because I want to have more focus to the environmental issues like climate change, and also I want to have an better understanding of what people lives in these rural areas. Legal implications is basically the cybersecurity part of this network. It's, as I say, I will use some cybersecurity protocols, but obviously if they are not like uncrackable, and if a person that has that SSI they have that WPA2-PSK key, they basically be able to access the network. For changing this, I'm planning to add two-factor authentication to this network in the future. But for the first part, I haven't added this, but it's still pretty safe. And also the webcam of the home can be maybe concerning if there's any hacking issue. But mostly, we can say these protocols are pretty safe. And this Internet of Things technology is really new and it changed a lot of things. Right now we can access from other devices while we're sitting here. And this obviously changes a lot of things in cities, but the main implication it will have is going to be on the rural areas, since in city, for example, your home and your the working place is mostly not so far, right? Maybe maximum 1 hour drive. But in some rural areas, as I say, their office might be so far to their home they need to be sure from their home safety. They might have kids in the home, they might have any other problem, and also, as I say, the rural areas are less preparable for these like natural disasters like bushfires, floods, or other things. So it's going to be really good for them. And this is a new innovation, new technology that's going to change a lot of people's life. Thank you very much for listening to me. Now I'm going to show you how did I make this network from the beginning.
So first of all, we're starting with adding a background image. I already downloaded the image, which is called home. It's going to symbolize the network that the part of the network that is in the home, and I'm just pressing apply, and yeah, here we got the image. And also for the different sections, there's going to be two different shapes. One of them is going to be green circle. This is going to represent our rural network instead of our home, so we will have a connection between them. So I'm adding a home gateway to both of these networks. That they are going to be the wireless connection of that local network, and I'm going to add a switch which is 2960. It's going to be get the mission of bridge between these two home gateways, so they be able to communicate through a IoT server. And I'm adding a red square and a server IoT server device because to represent the server part of the thing. And right now I'm adding the IoT devices to each of the networks. So as you can see, I add the coffee machine, door, garage to my home network. This is going to be the home part of the network, and also webcam for the safety issues. So I'm changing the name of the home network to home gateway, and the office one to the office gateway. It's going to be more easy for me to do this. And also I'm changing the SSID as well. SSID is basically the communication protocol between the wireless network. So it's going to show which IoT devices that each device is going to be connected to. So right now home gateway has the name of home gateway, and the office gateway has the name SSID of office gateway. So I also add the fan one detector and thermostat to my office network, because, and also the temperature monitor, because they're going to, this is a rural office network, so it's going to show like the important issues, like the weather, like temperature and other things. Since it's in a rural network, these are really important issues, especially in like remote areas, like the main goal. And also I'm adding 2 tablets for each network, so each network will, this tablet's going to let users in each network to access from the other sites. And I'm right now I'm just changing display names of the each IoT device, and also writing typing SSIDs accordingly. So I'm basically for the home network it's already typed home gateway, but for the office network I need to type the office gateway for the each IoT devices. Thanks to that, they're going to be connected to this home gateway. Yeah, I'm changing to the office gateway. So I have 4 IoT devices for each of the networks, and they're going to be connected to their local home gateway. One of them, as I say, called home gateway, and another one is going to be office gateway. And also, by the way, these tablets are going to be connected to SSIDs. So they're all going to be in one network, and these 2 networks are going to be connected. You'll see soon. So I'm changing the SSIDs, as you can see. And right now I'm changing the SSIDs of just checking twice that I wrote everything correctly. Yeah, I'm changing the name of the one detector as well, so it's going to be easy for me to like navigate all these things while changing their name, because like when Cisco software just opens it, it's gonna say a random name like IoT device blah blah blah. So I don't want that. I want them to give a specific name. And I'm adding SSID to these tablets. As you can see, I wrote office tablet and changing the SSID to the office gateway, because that was the, as I said, the SSID of the local network, the local home gateway, which is called office gateway. And also I will do the same thing to the other tablet. Before that, I also will change the names of each devices, because as I said, like, going to be more easy to navigate. So coffee machine, obviously this guy will need coffee, right, when he comes to home. So when he works, he can already press the button, and when he arrives at home, the coffee is going to be get prepared. So that's gonna be really easy. And also webcam, like webcam is really important actually, because when you have 2 hours between your home and your office, you don't know what's going on. You may have kids, you may have other things, and thanks to this webcam, you'll be able to see. And also door, like maybe you have a neighbor that comes in or an important person that needs to come, so you can access both garage and door when you are at work, which is really far to your house. So it's going to be really, they're gonna make it really easy for them. So right now I'm changing the SSID of the home tablet. So yeah, as you can see now, all of the local networks has connected. So all I need to do is like having a cable connection between them. So I basically connected the internet of home gateways to the switch, and switched to the Ethernet of the server, the Ethernet of the switch to the IoT server, and they're all connected right now. And also I'm writing an IP to this server right now, which I chose 192.168.1.10. So that's the attempted IP attempt, and also the default gateway of 192.10.168.1.1. So thanks to that, it's going to be easy to like navigate. This is basically for navigation. I'm typing the default gateway again to the DHCP part of the server right now. So default gateway is basically navigation between these ones. So it's kind of like not passcode, but the server recognizes this pattern and like just connects them each other, so they need it. And I also changed the DNSC server to the address, and I say serve and the start IP address. So it's gonna start at ending at 11. I'm gonna attempt the different IoT address to each other. And right now I'm trying to register for the IoT address. I'm just writing default username and password, which is admin, and as you can see, I connected, so it works. It basically works, which is good news. Yeah. Right now we haven't connected any of the devices, but we can see that they connect. They are the IoT server works. So let me try first one. So I'm typing the IoT server to remote address and server address and username password, like the admin, and it's connected. So let me try, is it working or not, just for testing. Just typing the IP address and username and password. And yes, as you can see, we connected the store, and I can unlock or lock from the IoT server. So I need to do this for all other IoT devices. I'm basically typing the server IP, username and password for each IoT device, and like connecting them basically. It's gonna take a bit time. Basically saying going config and IoT server to home remote server. This means that you can access this from anywhere, which makes it really easy. As long as you have the internet connection, you basically use and of course your internet connection to your local network. You can basically type the IP of that web browser and access it, as I'm doing right now. As you can see, it works. Congratulations. Yeah, I connected 4 of these ones, but I need to do for the other network, which is office gateway. So I'm basically doing the same process, just like typing the server address, username and password, and also accessing the DHCP, which is the default information. So because of our home gateway is connected to switch, and also the server via switch, it basically gets the information of default gateway and subnet mask and the DNSV server automatically. So by saying DHCP, like from gateway, I'm just making it easier. So I'm just saying that get the default results and use that. So I'm trying, yeah, writing the IP address, admin, And yes, as you can see, we have 8 devices that connected. We can control the thermostat. We can give any temperature. We can control the fan if like it's so hot or it's not cold. We can do the coffee, so we can do, and also we can watch our home from webcam, as you can see, like all the device that we connected. Yeah, garage, we can open the garage. So it makes it really easy for them, but we have one final step. We need to put the cybersecurity part of this, because we want this network to be accessible. So I'm basically writing the WPA2-PSK, which is the kind of like Wi-Fi code. You can think like that. So I'm attempting a Wi-Fi code of stay sharp for my home gateway. So every devices should have this code to access their local home gateway. So I need to write them all. Stay sharp. This is basically how your Wi-Fi works in your home. If you have the password and you know the name, you will have a connection to that. This is also a really good protocol called encryption AES. So I'm writing the stay sharp to each IoT devices, so I'm being ensured from their cybersecurity. Even the tablet, because it's also, as I say, the part of our local network in home gateway. Yeah. Let's check, is it working? Again, we should see 8 device again. Admin. We always should, yes, and we say 8 devices, so it works. It basically works. Let's do it. We need to do the same process for other network, the rural office network, but I want to put a different passcode, so it's going to be more safe. I'll put not sharp. Yeah, the other one is stay sharp. It's saying sharp, but this is not really sharp, unfortunately. Yeah, adding not sharp to each of the IoT devices. So basically, it's, as I say, going to secure our connection, and it's kind of like cybersecurity part of it. So not if you put a random IoT device, it won't be able to access that local home gateway, which we call office gateway, if it doesn't have the Wi-Fi, that passphrase. So making it safe, because otherwise, like, imagine any IoT device will be able, as long as had that SSID locked in, will be able to connect that, and it's not safe because you don't know what can happen. And we checking it again for each of the servers. Admin, and yeah, it basically works. We connected them for 8, all of the ones. As you can see, I use like webcam, I can use thermostat, I can change everything. So this is a secure network that you can access from both home or at office anytime. As you can see, I can unlock the door. You can choose who's coming in. You can check from webcam, is there a thief or a friend, or maybe in-laws. You can check it, and you can open these doors or garage that they're coming or not. So yeah, and also, by the way, you can also use the IoT monitor. You don't need to type the IP server. So as you can see from the IoT monitor, I just typed the default names, admin, and yeah, basically I can access it both tablets. So whenever I'm in office, I can access to my home, or whenever I'm home, I can access to my office. So as I say, this is really secure right now, and it's innovative technology, because this kind of thing wouldn't be possible just maybe 30 years ago, when like internet was really new. But now we can, sitting at the home, and control things in the office. So it's going to be really safe and really innovative in the way. As you can see, we can check the weather and like adjust.
So that was how basically I did all these things and implementations. I believe this network will be really helpful to the rural communities. Thank you very much.